Hello everyone. So this is a question from JEE Advanced 2025, paper 2. An electrochemical cell is fueled by the combustion of butane at 1 bar and 298 Kelvin. Okay. Its cell potential is X by F into 10 power 3 volts, where F is the Faraday constant. Okay. The value of X is, okay, we are supposed to find what is this X. Okay. And use standard Gibbs energy of formation at 298 Kelvin R. Delta F G naught of CO2 is minus 394 kilojoules per mole. Delta F G naught of water is minus 237 kilojoules per mole. Delta F G naught of butane is minus 18 kilojoules per mole. So the chapters involved is electrochemistry, thermodynamics, and redox reactions. Okay. So the cell given in our question, that is this particular electrochemical cell, is an example of fuel cell. Okay. Fuel cells are devices that convert energy produced during combustion of fuels. For example, hydrogen, methane, methanol. In our case, it is butane. So it converts the energy produced during combustion of butane directly into electrical energy. And this conversion is possible because the combustion reactions are also redox reactions in nature. Very important. Okay. So fuel cells are devices that convert energy produced during combustion of fuels, like for example in our case butane, directly into electrical energy. So it's a type of a galvanic cell, and this is possible because combustion reactions themselves are redox reactions. Okay. And so in the butane oxygen fuel cell involves combustion of butane, and the reaction will be C4H10 plus O2 will give us CO2 plus H2O. Okay. And uh, let's balance this 4 5, and here we'll have 13 by 2. Okay. So the voltage of this cell can be calculated by first calculating delta R G naught. What is delta R G naught? Delta R G naught is standard free energy change of the reaction. Okay. Which reaction? This particular combustion reaction that I'm talking about. Okay. So the voltage of this cell can be calculated by calculating this guy from delta F G naught values. Okay. And these values are given to us. What is delta F G naught? Delta F G naught is standard free energy of formation, okay, of the products and reactants involved in the reaction. And then we can use or apply the relation, that is delta R G naught is equal to minus NF E naught cell. So this is how we are going to approach our problem. Okay. So we know that delta R G naught is equal to sum of standard free energy of formation of products minus sum of standard free energy of formation of reactants, right? From thermodynamics, we can also write this in this fashion. Instead of writing sum, we can use this summation sign. Summation of delta F G naught of products minus summation of delta F G naught of reactants. Okay, cool. And in the combustion equation, the products are carbon dioxide, 4 moles of carbon dioxide and 5 moles of water, and the reactants are 1 mole of butane and 13 by 2 moles of oxygen. Okay, so therefore delta R G naught will be equal to 4 into delta F G naught of CO2. We have to take 4 moles because it's an extensive property. It depends upon the number of moles. Okay. So that's why 4 into delta F G naught of CO2 plus 5 into delta F G naught of H2O. So this is for the products minus bracket open 1, since we have 1 mole of butane, therefore 1 into delta F G naught of C4H10 plus, since it is summation of the reactants, and also we have 13 by 2 moles of oxygen, so therefore 13 by 2 into delta F G naught of O2, right? And we know a very important fact, that standard free energy of formation of elements is 0 and O2 exists in the elemental state, so therefore this value is going to be 0, and 13 by 2 into 0 is going to be 0, right? So therefore we can write delta R G naught is equal to, and these values are given to us in the problem, delta F G naught of CO2, delta F G naught of H2O, delta F G naught of C4H10. These are given to us. So substituting these values, we will get 4 into minus 394 plus 5 into minus 237 minus of minus 80. This value is given to us as minus 80. Okay, and when you do this calculation, you will get your delta R G naught as minus 2743 kilojoules per mole. Very important. Be careful, it is kilojoules. Okay, so now we know delta R G naught. So to use the equation, delta R G naught is equal to minus NF E naught cell. To use this equation, we have to know N. We know delta R G naught, F is a constant. So therefore we need to know N, which is the number of electrons involved in the reduction half or in the oxidation half. Okay, N is the number of electrons involved in reduction half or oxidation half. Okay, to calculate N, first let's calculate the oxidation number of every element involved in the combustion equation, that is in this reaction C4H10 plus 13 by 2 O2 giving us 4 CO2 plus 5 H2O. Let's calculate the oxidation number of every element in this. Some rules for assigning oxidation numbers which will help us is, the first rule is oxidation number of all atoms of different elements in their respective elementary states is taken to be 0. Very important. Oxidation number of all atoms of different elements in their respective elementary states is 0. So therefore in O2 the oxidation number of O is 0. Okay, and the second rule is the oxidation number of hydrogen is +1 when combined with nonmetals. Very important. For hydrogen it is +1 when combined with nonmetals. Therefore in C4H10 and H2O, since hydrogen is combining with oxygen and carbon respectively, which are nonmetals, the oxidation number of H is going to be +1. Okay, and the third rule is the oxidation number of oxygen is -2 in oxides. Okay, so therefore in CO2 and in H2O the oxidation number of O is going to be -2 in both of them. So -2 -2. Okay, so therefore we don't know the oxidation number of carbon in C4H10 and in CO2. Okay, so to calculate the oxidation number of carbon in C4H10, assume it as X. In C4H10, assume it as X. For H we know it is +1. Okay, so therefore 4 into X plus 10 into +1 is going to be 0, as the overall charge in butane is 0. So therefore X is going to be minus 5 by 2. Okay, so it is minus 5 by 2. And to calculate the oxidation number of carbon in CO2, assume it as X. For oxygen we know it is minus 2, so X plus 2 into minus 2 is going to be 0, so X is going to be plus 4, so it is plus 4 here. Okay, so therefore I will rewrite the combustion equation, which is C4H10 plus 13 by 2 O2, giving us 4 CO2 plus 5 H2O, minus 5 by 2 plus 1 plus 1, 0 plus 4 minus 2 plus 1 minus 2. Okay, and in the hydrogen oxygen fuel cell we use concentrated KOH oblique NaOH solution as the electrolyte. Okay, if I draw the rough diagram of the hydrogen oxygen fuel cell, it looks something like this. Okay, so here we allow this is the inlet for hydrogen, this is the inlet of oxygen. Okay, and this is a porous anode, it is made up of porous carbon. Similarly, this is cathode of porous carbon. Okay, and here we have concentrated aqueous KOH or NaOH as the electrolyte. Okay, as our electrolyte. So therefore there are basic conditions. So therefore assuming basic conditions in our butane oxygen fuel cell also. Okay, so and if you look at this closely, from minus 5 by 2 it is becoming 4. So this is the oxidation half, because the oxidation number is increasing from minus 5 by 2 to plus 4. So therefore this is the oxidation half. So I will write it down separately. That is C4H10 and becoming 4CO2. Okay, so after balancing atoms other than H and O, that is carbon is balanced, you can see 4 carbon, 4 carbon. Okay, so first balance O atoms by adding H2O molecules to side deficient in O atoms. Okay, so balance O atoms by adding H2O to side deficient in O atoms. Okay, and here the side which is deficient in O is the LHS, this side. Okay, and what is the deficiency? Here we have 8 oxygen, so therefore I will add 8 molecules of water in the LHS. Okay, so therefore we will have C4H10 plus 8H2O giving me 4CO2. Okay, so oxygen is balanced. Then to balance hydrogen, add H2O molecules equal in number to deficiency of H atoms and then equal number of OH minus to opposite side of the equation. Okay, very important. These are in basic conditions. Okay, to balance H, add H2O molecules equal in number to deficiency of H atoms and an equal number of OH minus to opposite side of equation. And H is deficient in RHS. You can see here we have 10 hydrogen and 16, that is 16 plus 10, we have 26 hydrogen in the LHS and 0 hydrogen in the RHS. So the deficiency of hydrogen is in RHS and the deficiency is 26. So therefore add 26 H2O, 26 molecules, moles of H2O in RHS. So it will become C4 H10 plus H2O, 4CO2 plus 26H2, right? And we have to do a step simultaneously, that is add H2O and an equal number of OH minus to opposite side of the equation. So in the RHS, we added 26H2O. So therefore, we will add 26OH minus in the opposite side of the equation, that is the LHS. Therefore, the final equation is C4H10 plus 8H2O plus 26OH minus 4CO2 plus 26H2O, right? Now, charge is not balanced in this equation because there is minus 26 unit charge in LHS and 0 in RHS. So therefore, I will add 26 electron in RHS. Therefore, the final balanced oxidation half is C4H10 plus 8H2O plus 26OH minus 4CO2 plus 26H2O plus 26 electron. You can minimize it further, 8H2O and 26H2O. So remaining we have C4H10 plus 26OH minus, giving us 4CO2 plus 18H2O plus 26 electrons, right? So therefore, from here in the oxidation half, N is 26, and obviously it will be the same in the reduction half also. So to practice such kind of balancing of half cells, there is a question based on balancing of half cells asked in JEE Mains 2026, whose link you will find in the description. Okay, so we got the value of N. So therefore now we know that delta R G naught is equal to minus NF E naught cell, and delta R G naught is minus 2743 kilojoules per mole, and minus 26, and value is 26 into F into E naught cell. They have given us in the question as X by F into 10 power 3 volt. This is given to us in the question. Okay, and I will write this kilojoule in terms of joules. Okay, so minus 2743 into 1000 equal to minus 26 into F into X by F into 10 power 3. So this 1000 and this 10 power 3 gets cancelled. This F and this F gets cancelled. So we are left with, this gets cancelled. So we are left with minus 2743 divided by minus 26 is equal to X. Therefore, X is going to be 105.5 when you do this division. Okay, therefore the answer is 105.5. So the value of X is 105.5. Okay, thank you.